how are you? Let's summarize some of the concepts that we have been studying in class these days, all right? First of all, root of a polynomial. Root of a This concept is very, very important. A is a root of the polynomial p of x if p of a equals 0. This is something you have to know. We call a number a root of a polynomial if when we place that number in the place of the variable of the polynomial, we obtain as a result 0. Let's see an example. Suppose we have the polynomial 3x cubed plus this, minus this, minus this. If I plug in this value, we obtain 3 times minus 1, that is negative 1 cubed, equals negative 3. Negative 1 squared is positive 1 times 2 plus 2. Negative 3 times negative 1 equals plus 3 and negative 2. Since the result, when we place negative 1 in the variable is 0, we can conclude that negative 1 is a root of our polynomial. All right, let's go on. Now we are going to talk about the reminders theorem. I'm going to erase this. The reminders theorem says that if we divide a polynomial by x, the variable, minus a number, let's call the number b, we would obtain a quotient and we would obtain a remainder. And this theorem says that if we calculate p of b, so the value of the polynomial, the numerical value, placing b in the variable, we will obtain the value of the remainder. And the reason why is because if we use the proof of the division, we would say that this polynomial would be x minus b times this plus r. You have to remember the proof of the division. If you don't, you can try like this. 13, for example, divided by 3 would be 4 and the remainder 1. And now it's easy to see, it's easy to remember that 13 equals 3 times 4 plus 1. So here it works the same way. This times this plus this must be this. Okay, so this is true for every value of the variable of the polynomial. Let's say that we consider that x will be b for us. So we can write, instead of x, always we write b. P of b would be b minus b times c of b plus r. b minus b is 0, and 0 times something would be 0. So we obtain the reminders theorem that says that if we substitute b in a polynomial, we obtain the remainder of dividing that polynomial by x minus b, the number. All right? Let's work with an example. Let's say we have the same polynomial than before. And we are going to divide this polynomial by x minus 2. We can obtain the remainder of this division directly without performing the division. And that would be just calculating p of 2. Let's do it. It would be 2 cubed, that equals 8 times 3, 24, plus 2 squared, that is 4 times 2, 8, minus 6, minus 2. And this equals 8. Let's work with this before. 8 minus 6 equals 2, 2 minus 2, 0, so the remainder would be 24. We are going to check this remainder using Rufini's rule to perform this division. And this way we have a little review about Rufini. So to perform a division by Rufini, we have to write the coefficients of the dividends of the polynomial. that we have as a dividend. So we write 3, degree 2, degree 1, and degree 0. If some of the degrees is missing, remember you have to write 0. And now we have to write this number changing the sign. And we obtain. We pull down the first term, that is 3. 3 times 2 equals 6. 2 plus 6 equals 8. 8 times 2 equals 16. 16 minus 3 equals 13. 13 times 2 equals 26. And 26 minus 2 equals 24. And this is exactly the remainder that we obtain using the theorem. So it is correct. To finish with Rufini's, let's write. The remainder is 24, as we said before. And let's write the quotient. Because with this method, we obtain the division. We can solve the division. We can obtain the quotient and the remainder. And the quotient is written here in Rufini's way. So we have to write these coefficients in as a polynomial. So this would be the number degree 1 and degree 2. And our quotient would be this, plus this, plus this. And this is over. I hope you understood. If not, let me know. Bye!